Hey, Dr. Henry, can I ask a question?
Same time.
Yes, you can.
Do we have the lab uploaded just yet for the one that we discussed we were going to do on Wednesday?
This
Or-
last Wednesday?
Yeah.
Yeah, it's up. It's up on your Calendly show. It's lab number 9 for you guys.
I was gonna ask about lab 8. Do you remember when we went over that in class, what lecture that was?
That's chapter 8.
Chapter
And we
8.
went over balancing chemical equations already. You're going to be going over it some more next week as well too.
Okay. Thank you.
Dr. Henry, I think some people, they're in the lab Zoom right now.
Yeah, I
let
just
me-
came from there.
So I left a message in the chat that everyone's in the office hours, but you had like 7 or 8 people sitting in there.
Okay, let me go see.
Okay.
Do any of you guys have the list? Because I know it was the balloons, the vinegar, the water bottles, and the measuring cups and spoons. And was there anything else?
Baking.
Okay,
Yeah.
thank you.
And you'll need a permanent marker to mark your balloons or water bottles.
Thanks.
You're welcome. Oh, measuring tape, you have that?
Or a ruler.
Or a ruler?
Oh, okay.
Hey guys, are we supposed to start doing this by ourselves or?
No, I think
we're waiting for him.
okay, good.
Wait, we need a measuring tape because you didn't say we needed one.
Yeah.
You can use a ruler.
Apparently.
Do we need 5 or 6 balloons? Because I'm looking at her sheet and it says 6, and I remember he told us we needed 5.
You need
Yeah,
six.
yeah, but he said we need 6 now.
Damn, all right.
Do we also need 6 water bottles?
Yes.
Okay.
Okay, are you guys there? Let's see. Is this? Oh, it's just me. Everybody's in the right place then.
Yeah, we're here.
Okay, everybody's in the right place. I just went to the lab and. Okay. So you guys have you got your bottles all set up?
Yes.
Yes.
And you have your balloons already labeled?
No.
No.
Okay, label your balloons. You don't need me to hold your hand. You guys act like, what, do you want me to come there and pet your hair while you do it?
Do we label them like balloon 1, 2, 3?
Yes.
Yes.
Label it to 6. You actually have 6 samples, not 5.
Or A through F.
Okay, so what you guys gonna do, you're gonna weigh, not weigh, you're gonna take your teaspoon and you're gonna get 1/4 of a teaspoon and you're gonna put in your balloon. The best way of putting in your balloon is getting a piece of paper or an envelope or something like that and making a makeshift funnel, or if you have a funnel, use your funnel. Okay, any questions?
Dr. Henry, can I ask one more question?
Yes, you can.
You guys are doing a different lab for a different class, so I can record myself doing my own, but
Yes.
in the modules, I don't see anything past lab 5.
Okay, let me take a look and see.
Um,
Check under your under graded items because it'll show up there.
okay. Oh, okay.
You see it?
All right. Yeah, I'll probably just work on this one
Okay,
Thank you so much.
no problem. And you can stay in, you know, I mean, even though you're doing a different lab, that's fine.
Okay.
So the tablespoons and the teaspoons, I mean, that we're using, you said put baking soda, right?
That's right. So you're gonna put your
Okay.
baking soda, and then you're gonna use that to put it in your balloon. So, or you're gonna use a little funnel, makeshift funnel to put it in your balloon. So you wanna
Okay.
put it in a balloon,
Are you going? I need to put it inside the balloon.
inside the balloon, yes.
Okay.
This is a weird question, but I have cleaning vinegar. Is that gonna work the same as the regular vinegar?
Yep.
Okay.
Well, cleaning vinegar is basically diluted in most cases. So it's still gonna work the same, gonna have the same effect, but it may not be as dramatic. So
Okay, so we pretty much will use better the regular vinegar.
it would be better to use regular vinegar typically.
let me see
I
what
believe
happens.
cleaning vinegar is a little dilute, so.
Yeah,
little
that's what,
dilute.
it seems different and it has like little bubbly, so I'm like, oh, okay, never mind, I found some.
Okay,
Dr. Henry, so I have apple cider vinegar. Would that work?
yes, that will work. Yeah.
Okay.
Apple cider vinegar is just vinegar that hasn't been distilled,
Okay. Thank you.
completely distilled.
Lord, how are we supposed to get the vinegar inside the balloon?
You're not supposed to get the vinegar inside of the balloon. You're supposed to get the baking soda inside.
I mean, yeah, the baking soda.
Okay, so you make a funnel or you take a funnel. If you have a funnel in your kitchen, you can make a funnel with a piece of paper. Just roll it up like this. And it works beautifully. There you go. See? Ingenuity, right?
There we go.
Dr. Henry, and you said it was 1/4 of the baking soda?
It is the first one, A is 1/4 of a teaspoon. The second one is a half of a teaspoon.
And then spoon and half.
Dr. Henry, do we need a measuring tape for this?
Do you need a? Yes, the measuring
Measuring?
tape works better, or you can use a ruler. Veronica, where's your road dog? Why isn't he there with you doing the lab?
know. I don't know. We haven't contacted each other.
Hmm.
Feel like a criminal. If you know what I mean, like when people do it, where they take them and where they put them.
Oh. Okay, you're not supposed to be snorting the baking soda.
Who's doing that?
So my helper says she feels like a drug dealer right now. So she's using up. That's my daughter from high school.
Right? Good thing my kid's in here.
Oh. Hold on. Let's check it in there. That's problem number 2. Problem number 3. Number 3 is 1, 2. So hold it. Mm-mm.
Oh yeah, that's hard to open.
Okay, we'll hold it. Oh no, we're gonna need a funnel.
For
that one.
Oh, you're gonna make one?
Are you struggling there with the tape measure, Edgar?
Yeah, it's an old one, so it's super stiff.
Yeah.
You can hear it cracking. Si puedes, mom. Uno más bueno.
Okay.
Oh, yeah, pardon. You made it crooked. Hold this.
Make sure to hide all the evidence, you guys. And then add 1/3 cup of acid or vinegar to each of your empty cup.
Hold enough.
No, 1/3.
All right, go.
Edgar, are you wrapping it around the balloon?
1, 2,
Edgar,
3.
are you wrapping it around the balloon?
Yeah, I mean, I read diameter, so I read around.
No, diameter, that would be circumference.
Oh,
Remember 6 we got rid of, so it's 1.
I need to
Just
retake math
line
then.
it up.
What's
Yeah, just line it up and then you can eyeball the other side of it. Yeah, like that.
all
Or
right?
it-
Makes a lot more sense.
Yeah. That way it won't crack on you anymore.
This is why I keep failing math.
You got this.
2 of those. 2 of those exactly, okay?
Ese también. Eso está bien.
Another one. And then 6 is going to be 1 big tablespoon. Yeah.
This is the big tablespoon, mommy.
Yeah.
That's 1/16 of those.
He looks like a professional. Look at her gloves.
Instead of saying that.
No paper. Put it back. Oh, crap. No, we can't put it back.
Okay.
Dr. Henry, so do we start putting the balloons around the water bottles?
Yep, when you're ready, you got them all made.
I got them all, I have everything ready and then like, okay.
Okay,
then what do
and
we
get your ruler ready, and then you put your first one, and then you measure it.
So I'm measuring around it.
No, you're measuring from side to side, so the full diameter. If you measure around it, that's the circumference.
I'm sorry, so I'm just gonna basically do this, right? How big it is?
Let me see I have to find your screen, sorry. There's a lot of you guys, so you gotta bear with me. Yeah, so you're just gonna do that, yes. See how wide it is, yes.
Go in.
Diana, did you just get in from work?
Yeah. I was trying to pay attention at I got off of work and then I took my daughter to softball practice and I was trying to listen to class and then I'm here.
Okay. Oh, look at one.
Careful, mommy. You need to shake it. You have to put it.
Pull it up.
Okay, pull it up. Yeah.
Yeah.
Oh.
Dr.
Measure
Henry,
it
so
whenever.
just like,
Goes up.
put on top the balloon, the bottle, yeah. Right?
What was that?
Do I have to put like, the
You
balloon?
don't shake it.
Let's get it bigger.
Yeah, put the balloon on the bottom. Completely, yeah, you want to put it completely on the bottle, and then you're gonna lift it up and put the powder into the
Okay,
vinegar.
okay.
Dr. Henry, do we shake it?
Just kind of shake the top of the balloon to kind of get it all, yeah.
Oh, that's hard.
Did it stop? Was that your first one?
Yeah.
Hard.
Okay, so you want to measure the diameter?
Okay.
It's so cold.
Are we doing it in inches or feet?
Feet.
No, you're not gonna do it in feet. You want to do it in centimeters if you can, because if you do it in inches, you're gonna have to convert.
Just kidding.
Okay. That was 2.2. Oh, we're doing centimeters on.
Hey, Dr. Henry,
Yes.
what is labware?
2.75.
What do you mean by labware?
For the materials for lab 9, it says we need labware. LABW.
Yeah, labware, as in your beakers.
Apron?
Yeah. So you're gonna need 3 beakers and
Second one.
Yeah.
I can do an estimate, right?
So just everything that's on the list.
yep.
Imagine how big the number 6
Diameter?
is. Be careful, mommy.
I'm gonna blow up the house.
Dr. Henry, what would happen if I just like started flying away with the bottle? in my-
1, 2, 3.
I would start laughing.
We're not gonna blow up the house, right?
No, you're not gonna blow up the house. Not yet.
Whoa, 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 whoa. Number 2 is a lot. Imagine number 6.
There's a leak.
Hold it, mommy, hold it. Where'd it go?
This is a little bit bigger.
No, it feels hard.
Okay.
Hey Daisy, for yours, did you put the balloons on each water bottle first, or did you do one balloon measure and then the next one?
Daisy, or the other Daisy?
What Daisy?
Sorry, Ortiz.
I did one at a time.
I did
One
like
at a
first of all, I like
Yes, because otherwise, if you leave them sitting there, they start going down.
Yeah, they
Oh,
deplete.
okay.
the difference, but
Good point.
balloons
2.25.
one by one.
Inches, so I don't know about
Oh,
that.
do one by one, Dr. Henry?
Yep, that's what I recommend.
Okay, number 3.
Number 3.
Dr. Henry, would it be possible that like 2 of them I measure the same thing?
Yep, that is possible.
Like 2 and my 3, they measure the same.
Exactly.
Yeah, exactly.
Dr. Henry.
Whoa.
Can you type it in the chat, please?
You measure in centimeters.
It's growing.
So that we're so lucky that you guys had the good one.
They look the same, 2 and 3. Let's see.
No, you just flip the balloon up.
But it's still growing. I think it's still.
Dr. Henry, are we just adding the baking soda into the vinegar and then recording the diameter of?
That is correct. Yep.
Yeah, this one is the same 3.25.
Oh my God, I'm scared.
Okay, you ready for 4?
You can put it and I will pour it in.
This is not 4, this is 5. Where's 4?
Where's 4?
We missed 4. 4.
4 the pretty one.
1.5 tablespoon.
Dr. Henry, I noticed that my first ones were a little bit bigger than the last ones. Is that okay?
It's probably on like 5.
You said your first one was bigger than your last ones?
Well, like my second and my third.
That's interesting.
Mm-hmm.
1.5.
Well,
Okay.
it's about like half an inch.
Thank you so much.
So it's these 2, grab them.
Okay.
Some of them are teaspoons, some are tablespoons. Don't get them confused.
I didn't.
You need to be careful with that.
Okay. Ready?
Hold on. Hold on, Paula.
Okay. One of that one and one of the other one.
Did it go in?
Big bowl.
Mush it.
Okay, so now we got 4.
4. Don't rip it, mommy. I want to put it in.
Do it down.
Ready?
Okay, go.
Whoa. Whoa, whoa, mommy, look at this. Looks like slime. This one there kind of looks like the same as
It's gonna
that.
be 4. Oh, yes, the 4. Yeah, it looks like it's gonna blow up.
I know. Don't blow up, don't blow up, don't blow up. It's going in the balloon.
So was that your first one, Tucker?
Yeah.
Measure what?
What about, how are you doing, Sal?
So far, I'm okay, except for my second one. I didn't wrap the balloon all the way around and had some air leak.
Ah,
But now I know.
It's very light. Number 5.
Here we go.
Imagine what number 6 would look like. This one, mommy.
Figure that out.
Put down.
You gotta get balloon 1.
Okay, ready? Set.
Hold on, and then you can shake it, okay? Oh shit, I ripped it.
Oh, they're bigger now.
I have a lemon.
Shake it a little bit and I'll write it down.
Go.
Shake it a little more.
Put it down, mommy.
You gotta be
Just this. Oh, what are you gonna do? Now, mommy.
Diana, because have your daughter lift up the balloon.
this one. Oh, which one? That one.
Yeah.
Oh, nice, thank you.
Oh, mom, look at the balloon. Right here.
So we gotta wait.
It's so cool. That is
How long until we start measuring?
Once it stops, then you.
Bubble?
Yeah,
Okay.
once it stops, then you measure it.
And we measure from side to side or up?
Side to side.
Diameter.
Thank you.
So it's like
Wait, around it, around like this?
No,
Just,
Just side to side.
just like that, the way you're doing it.
use it here in the cabinet, right on the left-hand side.
So all you're measuring is from side to side. You don't
Next to the
wrap the
stove.
measuring tape around it?
No, not around it. He said just side to side.
Oh, okay.
Dr. Henry.
Yep.
My daughter said it's okay for you, but not for us over here.
You said it's easy?
She said it's easy for you, but not for us.
That's a piece of cake.
because you know why? Because every balloon had a different measurement of baking soda. Yeah.
Everything, mommy.
So which one is that one for you, Deanna?
This one is my balloon number 2.
Okay.
Going to
Dr. Henry, if there was a rip in the balloon and the balloon like decreased, can we do another?
Yeah, you can repeat it. Yeah.
Okay, perfect.
Dr. Henry, is it okay if like the measurements are very near each other? Or was it supposed to be like a dress strict?
Not, so they should be different from each other in terms of, okay, give me a second, okay? Yeah, they should be different from each other. So like your very first one should be pretty small, and then your last one should be pretty big.
Was the biggest.
So let me see yours,
Oh my god.
Veronica.
Yeah. So the first one,
Yeah,
and this one is like, wait, let me see. This is the very last one, but then again, like, say like my fifth or my fourth, they're very alike. I
yeah,
think.
they're gonna be alike, those two,
Oh,
because that's what you're kind of expecting to happen.
yeah. I just have to do number 2 again because I ripped it.
Okay,
Is it normal for balloon number 3 to be bigger than balloon number 6?
no, it's not normal for balloon number 3 to be bigger than balloon number 6.
It should be like the same, right?
Yeah, they're gonna be about the same. Yep.
Okay.
Dr. Henry, my balloon 2, 3, and 4 measure the same, and my balloon 5 and 6 measure the same. Is that okay?
That doesn't seem normal.
Same with me. They're all kind of same.
So your first two should be smaller than your next 4, and 6 is kind of a definite variable because there's a couple things that are going to be happening there because you have so much in there.
Because like this is mine, Dr. Henry. These are my balloons, right?
Yeah.
And then these are my measurements.
Okay, and so you said 4 drop down.
It looked like well, it started at 10.5, then it went up to 11.
Okay. And then, but your other ones are at 11. So your number 4,
Yeah.
your number 4, your number 3, your number 4, your number 5, and your number 6 are around 11.
Mm-hmm.
Okay. And then your number 2 is lower than your number 3, and your number 5 is much lower than the others, right?
Yeah. So is that good or?
It'll be clear. I'll go down and get it. Give me a second. Give me 1 second. Okay?
Okay, I'm just gonna redo mine because they were like almost the same.
Really? All of them?
Number 2, 3, and 4 were they measure the same, and then number 5 and 6 measure the same.
Are they like when you say they measure the same? How different were they in terms of the measurement?
Like not even different enough. Like if you can see, watch, I'll show you. Like they're like almost the same.
Yeah.
And then like this is my 5 too. It's like the same.
Yeah. So that's your 3, your 3, your 4, your 5. Well, it depends on how much you put in. Your 3, your 4, your 5, and your 6 are going to be approximately the same. Your 1 and 2 should be different than the other 4.
My 1, it is smaller, but my 2 is, I'll just redo my 2 then. And then my
Okay.
6. I'm just gonna
Okay.
redo those.
So I have mine here on the table. Dr. Henry. I have mine on the table and then mine's measured different. So
Okay.
the first one was 5.5. The second one was 7. The third was 13. The fourth one was 13.5. Fifth was 14 and 16 was 6. I mean, 6 was 16.
That's interesting.
My mic is on.
Because you should have reached a point of saturation. So
Like for me, is it okay if they have a difference of 0.5? Like between like
yeah,
my
0.5 is okay. So that they're roughly about the same. Because remember, you're using a tablespoon, right? Or a teaspoon. And so you may be off by a little bit with your teaspoon. So like if they're within that range, that if they're within 0.5, you're pretty much on target, right? So like for your case, Deanna, all your ones in the very beginning, your 3, your 4, your 5, those are good, right? And then because they're all about the same size. And then, but that last one you said was like 16?
16.
Yeah.
1/6.
1/6, right? And the other ones were all 14-ish, right?
The number 5 was 14. Number 4 was 13.5. Number 3 was 13. number 2 was 7, and number 1 was 5.5. So we measure with the right spoon measurements.
You're measuring with centimeters, right?
Yes, with this
Yeah.
one right here.
Yep. Yeah. Okay. Well, just record the data. The data is what it is, right?
Yes.
And so, you know, it is what it is. There's nothing you can really do about that. And so we could try to explain it and try to figure that out. You know.
Dr. Henry, can I private message you my measurements in inches to see if I need to restart anything?
Sure, that's fine.
Okay.
Measurements in centimeters, right? Inches.
And remember, these are experiments. It's okay if you guys, they're not going to be perfect because, you know, we don't have the exact tools that we would normally have in the lab. And we still don't, even in the lab, we don't have the exact tools.
Great. The rules from number 4 and 5 don't make sense.
You're
Put the balloon on each bottle and then pour sodium bicarbonate into the bottle.
Okay, so 4 and 5 actually, so what you're doing is because you're putting the balloon on the bottle, right? You're physically putting the balloon on the bottle that has the sodium bicarbonate in it, right?
Oh, so it's from the balloons?
Yes. So you're putting the sodium bicarbonate in the balloons. And then you're putting the balloon on the bottle. Then you're lifting up the balloon so it goes into the bottle.
Okay.
Do you understand, Christina?
Yes.
So you've already weighed out your stuff and then you already put it in the balloons? Because it says like 2, it says weigh out your sodium bicarbonate, add to respective balloon.
Oh, yeah.
I'm curious, what if I put 2 tablespoons of baking soda in one of the balloons?
Oh,
Pretty much messed it up.
Where's the top?
you have to redo it.
Guess I think
Okay.
Okay, 2 of the big ones.
Okay, so do me a favor and go get a teaspoon. It's in the drawer. Do you know where the spoons are at? Okay.
So once we have our measurements, what do we do now?
Okay, it's the calculation. Let's see.
Meant the whole thing.
Yeah, there's like literally a little proof of it. That was the whole thing.
So you're good, Aaron.
Look at if you touch. I think no, there's still more.
Did you hear me, Aaron?
What happened?
It looks good, Aaron.
All right, I'm gonna convert them to centimeters and then just calculate the volume.
Okay.
Okay.
That one should get pretty big because we put 2.
Yep, you're doing them both. I'm just gonna watch. Okay. So what we're gonna do is, nope. They're gonna blow themselves up. Okay, we're gonna actually put, where's the baking soda? Yeah. No, that's vinegar. That little box that you can. Where's that? Okay. Okay. So what we're gonna do is we're gonna put it in the balloon because they finished their lab already.
I'm doing this right.
I got this. I got this, Ken.
You got it?
Yeah, I can open it.
Okay.
And that is.
No, we're not gonna open it from the top. We're just gonna open that one part. We want it to be open. You don't want it complete. Are you listening to me?
Yeah, but look.
No, but I don't want it to, yeah. I want it to be open on this side.
Oh, that way.
Yep.
Making it only three.
Okay. So what we're gonna do is, I'm gonna take this guy here.
Okay.
You're gonna hold the balloon.
Yeah.
You said it had to be in centimeters or inches?
Want to convert it all to centimeters so that we can do the calculation. We're gonna let everybody, so for those who are already done, yes, you can put your numbers in the chat if you want to. And again, you guys don't have to worry about, experiments are not gonna be perfect. Okay, that's one thing you need to learn now. So let me break your hearts right now. It's not gonna be perfect, but the thing is that you want to learn why it may not be perfect. That's what you want to think about. Okay. You gotta hold this still. Then I need you to do what you do.
Do that.
Got it? Yeah.
It's one of you do that, and
Okay, hold it. Yeah, hold it again. Hold it at the bottom. Okay.
This.
Okay.
Dr. Henry, I sent my stuff to you, direct message. Can you check mine for me, please? It's Heather.
Okay, you sent your to via what?
Direct message, private message.
Yeah. Okay, hold on.
We have to send our stuff in private message or?
No, don't send me your stuff private message. People just are sending me because they're worried about their numbers.
Oh.
That's they're fine. So just collect the data, do the calculations, right? Don't worry, it's not going to be perfect, right? Because
You're talking to me, you said that they're fine, mine are fine?
yeah, they're fine, don't worry about it, that's not crazy. They're all looking pretty good. Yes, they're all looking pretty good.
Okay.
Dr. Henry, to find the volume of a balloon, do we just use the formula to find volume?
Yes, so you're going to use the sphere, but you also have to remember you have a volume already in it, right? Because this has a volume associated with it. Okay, so you want to take into account the volume that you have there and subtract the volume of the liquid itself, right? Roughly.
So we have to find like a cylinder, the volume, a cylinder.
No, because you know the volume of this, right? What is the volume of a bottle? A 16 fluid ounce bottle. It also says 500 mils.
Would it be like using the formula to find the volume of a sphere, like pi?
Okay, give me a second. We'll talk about this together. Let everybody get their balloons together, and then I'll show you what you need to do. Okay, because you're overthinking it, right? Because you have the balloon. The balloon is going to be a sphere, right? So you're going to use the volume of the sphere. That's going to be the first part. So that's why you need the calculations. But you also need to add the volume of the bottle because it's a gas that's going to be filling up the bottle. Right?
Oh, we're just adding the volume of both.
That's right.
Oh,
That's
okay.
right.
I thought you wanted me to subtract. I was like, okay.
Nope. Okay. So, you ready? Okay, let me move some stuff out of the way. And you can't get it on my. Here, it's not. Okay, so this is the first. Okay, so what I'm going to do is put it on here. Then I'm going to lift up the volume.
So Dr. Henry, once we have all the calculations, once all the measurements, we just do the math and we're good to go?
Yeah, and I'll show you guys how to do the math here. I'm just trying to wait for everybody because I want to do it all in one sitting. I want to get everybody all done at once.
Okay, cool. That means we can go inside. All right, we don't need these anymore.
Your teacher's cool.
I know.
Don't pop the balloon, dude.
I messed up. It has a full.
Not helium. It's not gonna pop like that.
Oh, the hell would I ask? Yes, it is. Oh. There are your fingers.
I think you need to sharpen your knife, Sal.
Yeah, he's struggling.
What?
I think the balloon's winning.
Don't kill the balloon.
It's going in a balloon.
You still got this kitty.
Oh, that's cute. Now my hands smell like vinegar.
What? Can I draw a smiley face on this one? Where's the shirt?
Dr. Henry, so where everybody needs to put the measurements in the chat?
No. Do not put your measure. You guys are just, you're doing extra work. You're
Oh, because
asking.
I see everybody putting it, so I was like, oh, okay.
No. You don't need to put our measurements in the chat. I'm going to show you what you need to do with your measurements.
Great.
So when you're done, but what I'd like you guys to do, if you guys give me a reaction and let me know that you're done. So put your thumbs up if you're done.
What? No, I'm just kidding.
If you're done,
I'll
put
put
your
my thumbs up.
Okay.
Put your thumbs up if you're a thumb.
Okay. Anybody not done?
Look at this guy.
Okay. Are you ready to do that? Okay, so
Christina, she needs help. I think.
Okay.
Still unmuted.
Okay. Then I have to show them how to do this. Okay?
No, don't worry.
Oh, this is my class. I would get in trouble.
Your teacher's stupid. I don't like your teacher.
At least your teacher's cool.
Because my teacher has a PhD. Your teacher is not smart.
She got 2 master's
Why do I
degrees.
put that?
2 master's degrees. Your teacher.
Ready?
Why does my mouth feel weird?
Hold up.
Unmuted.
I'm sorry. You're making me feel. What happens if I drink this?
It's not gonna taste good.
Will I die?
I don't know.
Careful with it. Okay, so let's start talking about this data. So I'm going to steal somebody's. Can't do this. Hold on. Oh, you will.
You can steal my data.
Oh, I'm sure I can. I'm going to make some up.
Can I keep this one?
Now lift.
I like the colors, pretty.
Okay, so you want all your units to be in centimeters.
Can you tie it?
Okay. And that's good.
Let it go up in the air.
No.
It goes
Okay,
down.
I see that.
Pretty. I was happy to do your participate and volunteer. What should you name it?
Okay.
Oh, it's soda.
Okay, so first thing I want you guys to do, here's a chemical equation. Is this chemical equation balanced? Yes, no, maybe?
No.
No?
Counting. 1 sec.
Yes.
Good job. Okay. Yeah, you can go ahead. What is water? No, this is water right here. Okay, so somebody said yes, it is, and somebody said no, it isn't. So
I'm checking.
okay.
When you turn it upside down, it says character with a cyclist and baggy eyes.
right back and go to the.
But I want
Okay.
you to, I want to be
All right.
alone.
I think it's balanced here.
No, that's enough. We'll just make it cloudy, like and blue.
No.
No, not right now. Not right now. Okay. Okay, so go watch a little TV while I do this. Okay. Okay. Then I'll be down later.
It looks balanced.
So I have another little experiment for you to do. You just gotta wait though. So it's just to keep it straight. Okay, so go down while I take care of this. Okay, so you guys, is it balanced or not?
Yes, it's balanced.
Yes,
It's
it is.
balanced. Okay, so we have a balanced chemical equation. This is the chemical equation that's going on. So we have sodium bicarbonate, and this is vinegar, acetic acid. And what you guys have just generated, so what do you think is in a balloon?
Maybe carbon dioxide.
It's going to be carbon dioxide. Okay, so you guys, you guys are calculating the volume, right? So do you guys know what is the equation for calculating the volume in the sphere, of the sphere? Because we're going to make the assumption that our balloons are perfectly round. Although they're not perfectly round.
4/3 times
Pi radius to the third.
yeah.
Pi r cubed. Okay, so you're going to be using this equation to calculate the volume. Now you're going to ask me, why are we calculating the volume? Right. So since the volume is going to be occupying the balloon and then also part of your bottle, right? Then we'll know, we can use that volume to calculate how much, or the number of moles that we actually have of carbon dioxide. Okay, and the way that we do that is there's the ideal gas law. The ideal gas law is pressure times volume equals nRT. Okay, P is for pressure. And this pressure is going to be basically the pressure of your environment right now. So in this case, we're assuming the pressure is going to be 1 atm. ATM, it stands for atmosphere. So that's the unit of pressure that we kind of use inside. V is going to be the volume. Now this volume is what you guys are calculating. But you're going to have to convert that to liters. So convert from cubic centimeters to liters. N equals the number of moles. R is the ideal gas constant. Okay, and that's going to be equal to 0.0821, and the units are ATM times liters divided by moles Kelvin. And then you have the temperature. And we want that in Kelvin. Okay, so room temperature is about 22 degrees Celsius. So if I want that in Kelvin, what do I need to do?
You had 273, right?
So that's going to be 295. Okay. Okay, so you want to solve this for n. So you're going to get, okay. Yep. Okay. So let's assume that we have a volume of 5 liters. It's a big balloon. Okay. So then if we plug this in and we calculate our number of moles, we're going to use that 1 ATM. Five liters divided by 0.0821. That's atmospheres, liters, moles Kelvin. Times 295 Kelvin. Okay, so if we look at our units, the atmospheres, liters are going to cancel out, the liters, the Kelvin, and then we're going to just be left with moles. Okay.
Does that say 0.206 moles?
Yeah, that's 0.206 moles. Yep.
But just the math, would that be 5?
That's assuming that, I'm assuming that when we did our calculations, I had 5 liters, just to tell you how I do a calculation.
Like the math to get the 0.206.
Yes.
Like be 5.
It'll be because it 1 atmosphere, so that's just 1 times 5, so that's 5 divided by 0.0821, and then you're also dividing by 295.
Okay, that's what I. So then all R's you just put in instead of the 5 liters, it'd be say 7 centimeters, right?
Yeah, if yours is, no, but you want to put it in liters. You have to convert it to liters. Otherwise, it's not going to work.
Oh,
out.
okay.
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 So you have to convert it to liters. You have to go from cubic centimeters to liters. Because that's what you're calculating here. So when you guys get whatever your value is here, you're going to have cubic centimeters because you're working in centimeters. And then, so what is the conversion? You guys have to look back, try to remember. We talked about it at the very beginning. Okay. So you're going to do that. Oops. Did everybody get that?
Yeah, so the only variable for us would be the liter portion. That's part
Yeah.
that's changing. Yeah, okay.
Okay. So then that's going to give us the number of moles of carbon dioxide. Okay.
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 Are we calculating any more elements?
Yeah. You're also going to be calculating the percent yield. Okay. So let me tell you what percent yield is. All this.
Are you gonna use a different color for percent yield?
You don't like the purple? Is that what you're telling me?
Oh no, I thought you were gonna use that same whiteboard with the blue.
Oh no, I'm
You
going
cleared
to
it.
different whiteboard. Okay, so percent yield. So there's 2 things that you need to calculate. First off, you need to try to determine what is the limiting reagent for each part of the reaction. So you're basically doing 6 different reactions. You want to determine which one is limiting, right? And you can kind of get an idea of when things run out, right? So what do I mean by limiting? How many of you guys like cheese sandwiches?
Me.
I love cheese sandwiches. Okay, so if the recipe for making a cheese sandwich is 2 pieces of bread, one slice of cheese, one of those really thick slices of cheese. And we get a sandwich.
Provolone cheese.
Okay.
I like a better grilled cheese.
Yeah, me too, with a lot of butter. So good.
Mayonnaise.
Okay. So if I have 20 slices of bread, and I have 15 slices of cheese, how many sandwiches can I make?
15. With cheese or without?
Cheese sandwich with
It's
15.
a cheese sandwich. So
15.
look at the recipe there. Are you sure?
You can only make
Could
10.
it be 10? Yeah, I think it's
I
gonna be
can
10.
only make 10
Oh, yeah,
sandwiches,
yeah,
right?
you're right.
Oh,
Right?
yeah.
Because for every sandwich, I need 2 slices of bread. Okay, so which one is in excess?
The cheese.
Okay, so cheese would be in excess. And which one would be limiting?
The bread.
Bread.
And bread would be limiting. Okay, so this is an example of a limiting reactant. Okay, so what you guys are doing, you're basically doing an experiment. The amount of vinegar or acid of acetic acid and sodium bicarbonate are not proportional to each other, right? They're not the right number in terms of quantity. And so your job is to figure out for each of those reactions, which one is going to be limiting. Okay, so that's one thing. So that means that we've got to make use of our chemical equation. So we know that we have, in this case, this is a balanced chemical equation. So we have a ratio of 1 to 1 to 1 to 1 to 1. So if I have 1 molecule of vinegar, I can make 1 molecule of carbon dioxide, long as I have 1 molecule of
Sodium.
sodium bicarbonate. If I have 1 mole of vinegar, I'm going to need 1 mole of sodium bicarbonate to make 1 mole of carbon dioxide. Make sense?
Yeah. What you get or what you put into it, you get out of it.
Yeah, so it goes back to the thing that we were talking about. Now, we use moles to sit there and help us to figure out how much stuff we're working with. So what the first thing you're going to be doing is picking up, calculating the theoretical, right? So theoretically, how much should we make of carbon dioxide if all of the sodium bicarbonate reacts? So for instance, let's say we had, do you guys, anybody remember? What is the value for balloon number 3? How much grams and grams did we add to balloon number 3?
6 grams.
So we have 6.0 grams, right?
Yes.
Of sodium bicarbonate. NaHCO3. Okay, so what is the molar mass of sodium bicarbonate? How do I calculate that?
Don't you take the atomic numbers of each? Like,
Is it the atomic numbers or the?
Atomic mass.
We want to make sure it's atomic mass, so we need the atomic mass of each. So how many sodiums do we have?
1.
1. Okay, so what sodium weighs how much?
Rounds up to 23.
Okay, so 23. Okay, hydrogen?
1.
How much does hydrogen weigh?
1.
Carbon?
Rounds down to 12.
And oxygen. How many do we have?
3.
3.
And how much does it weigh?
16.
So 16 times 3.
$74.
Okay, 74 grams per mole. So 74 down here, my mole up here.
I got 84.
You got 84?
Yeah.
Okay. Daisy, are you misleading me?
You were agreeable.
Oh, I am. Right now, I'm very agreeable.
Okay, kind of wrong. Sorry.
I've been up since 3, so I get very agreeable around this time.
My brain's shutting down too.
That's bedtime.
Yep.
Okay. Okay, so then what do you guys get? Well, getting carried away. So here, if I want to calculate how much carbon dioxide I made, then I look at the ratio between sodium bicarbonate and carbon dioxide. So we know that that's understood to be 1. So it's a 1-to-1 ratio. So for every 1 mole of sodium bicarbonate, I have 1 mole of carbon dioxide. And that's going to give me my moles of carbon dioxide. So what did you guys get?
0.714, yada yada yada.
0.5.
You said 0.715?
14.
428.
Zero.
Okay, so this guy would be my theoretical because that's what I'm expecting to make if I used all of it. So this guy would be theoretical.
Dr. Henry, would it only be 0.71?
Because we have 266.
That's correct. Good eye. Keeping me on my toes.
I'm just curious.
Wait, did you guys get 0.0714?
That's what I got too.
Yeah, 0.0714.
I got
Like-
0.7. 60 divided by 84.
6, it's 6, not 60.
Oh, that's
Yeah,
right.
so I got 0.0714.
Yeah, it's because the decimal was hard to read. 6.0 divided by 84 is 0.071, which would be 0.071.
So we're off by a factor of 10. Got it.
Yeah.
Keep misleading me. So I'm gonna have to pull out my calculator and do it myself now. Okay, so this is my theoretical. Okay. And my actual is what I get from the balloon, right? From the volume of the balloon when I did that calculation. I don't know what it is. Let's assume that it was, what did we get for the last one? It was 2. Oh, that doesn't make sense. So let's assume that is 0.0206 moles. Okay, so let's say that's what I calculated for my volume.
That's the value we calculated in the first one, right?
Yeah, I'm assuming. Okay. Okay, so if this is the value that we calculated from our balloon, then the way I calculate my percent yield equals actual. Actual is what you get from your experiment over your theoretical. Times 100%. So in this case, we would have 0.0206 moles over 0.071 moles times 100. Okay, what did you guys get?
29.01. 5 or 4.
Same. It's
It's
29.
29.07 or
Zero.
01?
01.
01.
Okay. Okay. Okay, and so then that would tell me that, well, obviously I didn't use all my sodium bicarbonate. It didn't work as efficiently as I thought. If I got 100%, then hey, it was be a perfect reaction. Everything balanced out perfectly. If it should either be a lot less than 100%, right? Or it should be less than 100% because 100% is the best you can get, right? So does that make sense?
Yes.
So if we put the exact amount of sodium bicarbonate in there, we would get 100%.
Yeah, if you did the calculation,
Right.
right? And you put the perfect amount and you got a complete reaction and nothing went wrong,
Yeah.
right? You should end up with 100%.
Okay. So does the percentage tell us like how far off we are?
Your percentage doesn't necessarily tell you how far you're off. It kind of helps you know whether or not you have excess or if you don't have excess.
Okay.
Right?
That's it?
That's it. And
Are
so,
we illustrating this work on the Excel sheet?
yes,
Right?
yes.
So we're
I'm
just
getting
gonna
you
be
guys
typing
using Excel. What was that?
We're gonna be typing in the formulas and then dragging them down like we did with the other lab.
That would be the smartest way of doing it.
And we're gonna do this 6 times because 6 balloons.
Yes, you're going to do it 6 times with 6 balloons, and you're also going to make a graph because you want to show me graphically where you think the point of excess kind of switches between the vinegar to the point where sodium bicarbonate becomes excess.
We're graphing the percent yield, right?
No, you're going to graph the number of moles.
Oh, I see.
Yeah.
And then we have questions to answer on top of that.
Yep. There's a few questions.
We can just answer that in the Excel sheet.
Yes, you can. And if you could do me a favor and save it as a PDF and upload it. Okay.
It's due next Friday.
Yeah, I think it is due next Friday because tomorrow we have lab 8, the chemical reactions one due.
Yeah, yeah. So I figured it's just like how it's been the last couple. Just wanted to make sure.
So you asked me is this lab due? Was that the question? It's due next week.
Next Friday?
Yep, next Friday.
Okay. Yeah, I'll probably bug you about getting the Excel to work next week.
Yeah, Dr. Henry, are you gonna like go over like the Excel, how you want it and stuff like you always do?
Yeah. Let's do that now so we can all get it done. So again, all you need to do is
Show us how to drag down like the stuff and
I'm not going to give you that much detail this time because I held your hand for the first one.
I've been working on an Excel sheet. I can like put mine up, see if it's good.
Perfect. Let's do that.
Okay.
I'll stop sharing. Let me save this real quick and then I'll stop sharing.
Wait, Dr. Henry, we keep all the values like the atmospheric pressure and the kelvins, right? For each?
Yes.
Okay.
Yes. Oh, wait. You're talking about, what do you mean by you keep all the values?
So when we're calculating our actual moles, what we got from the bottle. We just keep the 0.0821 atmospheric pressure.
Yeah.
Okay.
So
So we're only changing
Wait.
the liters. Okay.
wait. Let me make sure. Okay, say that one more time. So the unit should be moles, right? Because that's what you're
Yeah.
getting. If you looked at it, you cancel out, you're ending up with just moles. Let me go back to that. Okay. So if you do all of the calculations, the atmospheres and stuff like that, that all cancels out.
Yeah.
You're left with just moles of carbon dioxide. Does that make sense?
Yeah.
Okay. Yeah, but yeah, the pressure is going to be consistent, going to be the same. The temperature is going to be roughly the same. Okay. Okay. Edgar, go ahead and share your screen.
All right. Let me see. Here it is. Can you see it?
Move you over to my.
So far I haven't organized it or anything. I've just been adding to it in like the order of like questions we've been tackling basically.
Okay.
So diameter, first thing. Baking
Do you mind
soda.
making it? I'm a little blind, so do you mind making it a little bit bigger?
Yeah, absolutely. I'll bump it up to like 14 is good. Are you able to see it now, Dr. Henry?
Yep.
Yeah.
Okay. So
And
diameter. Yep. Volume. Okay. So yes, the only thing now you want to do is calculate number of moles. Yeah, perfect. Yeah.
Yes.
So and you want to share with them how you calculated your number of moles?
So for number of moles of baking soda, are we also calculating number of moles of carbon dioxide as well?
Yeah, you should be calculating the number of moles of carbon dioxide, and you're using the volume to do that, right? So you're going to use PV equals nRT.
Yeah, okay. So I'll do that right here just to show also how to do like the sum thing. So I'm just going to write it here to make it easy for me to remember. And it's equal to.
I think you're going to have to make it a little bit bigger.
Yeah, it set it back for whatever reason. PV over RT. So let's go. Set something here so I know it's what I'm doing. So equals sum parentheses pressure, which is just going to be 1 atmosphere. And I'll put this in parentheses as well. Times volume, which is going to be liters. So here, I click that and it's going to list it. Divided by RT, so R is already listed there. Times temperature, which I have listed there. So all I have to do is just click the little box and it'll automatically put it in. And it's saying value because it's got this. If I just delete that, boom. As long as I know. Let's see, so this is ATML over mol K. So that should be the number of moles of carbon dioxide using number 1, so bottle 1. So I'll just set like bottle, of course it's back to bottle 1, bottle 2, bottle 3, bottle 4.
Yeah, if you actually just drag down, it'll actually put the numbers in there.
A question, does this work for the theoretical yield?
No. So to do the theoretical yield, so you're going to have to do the calculations, right? So this would give you your actual value for your theoretical yield. This is going to give you your actual values, what you actually got. Your theoretical yield is just, once you have the number of moles of this guy, it's a 1-to-1 ratio, right? So you have a 1-to-1 ratio of the number of moles of baking soda to the number of moles of carbon dioxide, right? So in other words, these values are going to be the same number that you're going to get for theoretically for your carbon dioxide. So if you calculate your theoretical yield, it's going to be, or your percent yield, it's going to be, okay, you got to stop moving there.
Yeah, it's done.
Okay. Still teaching, hold on. We're doing the math behind it. Okay, so you're going to take your actual calculation and divide it by this guy and multiply it by 100. Okay, so this is your theoretical. Okay, and this is your actual. And this is only theoretical. Well, in all honesty, this value should be the same as this guy.
Yeah, it's just this one's just baking soda. So
Yeah.
we're doing baking soda divided by CO2?
No, so to get your theoretical yield for CO2 is going to be, since there's a 1-to-1 ratio, remember in the chemical equation?
Yes.
It was, let's see. Okay, it was sodium bicarbonate plus acetic acid yields CO2 plus H2O plus sodium acetate. Okay, so if we look at this chemical equation, it's already balanced. It's going to be a 1-to-1 ratio. So one of these is going to be able to generate one of those. So now that you have the number of moles, it's going to be the same value for your theoretical. So all you need to do is, in this case, is put equal to that same value. Okay, so then if you're calculating your percent yield, it's going to be your actual divided by your theoretical. Does that make sense?
Yeah.
Yes.
Okay, and that's it.
I have another question. What if it's not the same yield?
What do you mean by what if it's not the same yield?
Like if the theoretical yield is not the same as the actual yield.
That's what you're kind of expecting, because the only way that you ever get the actual is if you lie, cheat, and steal. Okay, because in reality, experiments, when you're doing two chemical reactions, you're always going to end up with a little less than you expected to get in reality. You know, the best you can get is 100 in theory, but in reality, because experiments are not as efficient as we think they are, because they often will have impurities. We're human, we spill stuff, and you know, so it always ends up working out that you never end up with 100%. You know, I never told you my story about when I decided I was going to quit chemistry, chemical engineering.
No.
Let me share. But I said I was going to quit. I was in college. I was going to quit college and just drop out. So I was taking a course called analytical chemistry. And analytical chemistry is basically you're always trying to calculate, you know, how much you actually get. And this was my first time. I'd never been in college before. Nobody in my family had ever been in college. So I was kind of at a disadvantage. So I thought when you did an experiment, you should get exactly what you calculate you should get, right? And then And this is analytical chemistry, so it should really count. So I was sitting there doing the experiment, did my calculations and stuff like that, and I did my percent yield. So the very first time I did my percent yield, I got 87.6. And I'm like, okay, so I must have screwed up. So did it again. I got 85.2. Okay, now it's not getting better, right? Did it again. So I'm like 50% off, right? And I'm like, you know, I'm good at this. I should be doing great. I should get 100% every time. So did it again, right? And, you know, I'm quick. I'm faster than everybody else. You know, I'm feeling pretty good about myself. And again, and, you know, at this point, everybody in the class is pretty much gone because they did the experiment the one time and everything like that. Except there's this one guy that was still there. And I asked him, I'm like, hey, what did you get? And he's like, oh, I got 100%. And I'm like, okay. So I thought, oh, man, I did it wrong, especially because I knew the guy. I'm like, man, he got 100%. He's not that smart, right? So I'm like, I should get 100%. Okay, so let me try it again. So I was a little upset. And my kid is like, Henry, you need to hurry up. You know, it's like, I got to go. I have some things to take care of. And I'm like, I know you have a class later tonight. Is there any way that I can come back tonight and try to finish it up? He's like, yeah, sure, you can come back. So I came back that night, did it again, you know, 86.7. So I'm like, okay, this is it. If it don't work, I am done. That's it. So I'm like, take my time, made sure, calculated the things all over again. 86.7. Now my numbers were very precise, right? But I was not at 100%. So I'm like, okay, this is bullshit. So I threw my lab notebook across the room into the garbage can, kicked the garbage can, and I went out the door, started walking out. TA comes out. Henry, what the hell's wrong with you? I'm done. I'm done. He's like, what's wrong? What happened? And he's, you know, talking me down from the cliff and everything. And I'm cussing and I'm like, you know, this sucks. And, you know, it's not meant to be and all of this. And I'm like, you know, I kept doing it. And I said, I never could get it right. I'm doing it wrong. And he's like, what are you doing wrong? He's like, okay, come here. Let's look at this data, right? So he's like, okay, 86.7. So, you know, he's like, okay. And so he took me to the back of the room. And then, so the jar that he had actually was the chemical. And if you look on the back of the chemical, it says that it was 86.9% pure, right? Meaning that about 14% of it was impure with other things. So there was no way in hell I was ever going to get 100%. But in my mind, I thought I was going to get 100%, right? So if you're getting more than 100%, obviously you're doing something wrong. But if you're getting less than 100%, that's normal. Moral of the story. And just because you get stuff wrong, don't quit. Anybody there? Did I make you fall asleep? Was it that bad?
No, that was a good story.
That was good.
No, it's good because that was about a drop.
Great.
That's a great story.
I was about to quit college because of work and then kids
Yeah.
and school.
Yeah, you can do it. Don't sell yourself short. I know it's rough right now, and believe me, I know it's rough. Like some of you guys haven't got a test back yet, so I know it's rough. So I'm working on it, and but stick with it. Stick with the class. You know, you guys are this close to finishing, and if you guys stay on top of it, keep on the homework, you're gonna be okay. Meet with your project. I've had people contact me. My project members have not contacted me at all. And so meet with your group members, get your project done. You know, that 10% really adds up in the end when you're trying to salvage for points. And you will be salvaging, you know, because I know some of you guys really want that A. So you're going to be salvaging for that A. Some of you guys are going to want that B, and some of you guys are going to be praying for that C, you know, so you want to make sure you get every point that you can possibly get. Okay.
Thank you for the encouragement, Dr. Henry.
I believe in you guys. I know you guys can do it. And I know it's rough. Don't think I'm rooting against you. I know it's rough. And so, especially right now.
I'd like to read a message to the class
Sure.
that I received from one of my instructors earlier.
Okay.
He said, to my knowledge and per the Heart Now website, tomorrow, April 23rd, is the last day to drop the course and still get a W. If you are struggling or just haven't done any work because life has been wild, you should probably drop yourself from the course. I do work with students to submit late work, but that can be a difficult road. There's no shame in dropping a course and returning when you're able to do your best.
Yeah. I also kind of believe don't give up on yourself because you guys, you've done a lot. You've made it this far and you guys are here, the people that typically don't care have already dropped the class or, so, but yeah, tomorrow, I forgot to mention that. Thank you for reminding me. Tomorrow is the last day to drop. So if you decide that you want to drop, then,
Is there for West Coast as well?
Yeah, it's not your last day to drop at Coalinga. Coalinga, I think your last day to drop is next week. You get a W, but it'll be your last day to drop is next week. Yeah.
But
Too invested now.
Yeah, your guys are invested. To me, I'm like, you've lasted.
We're too far into
it. And also, it's like if you stayed on top of the homework, I keep telling you that, stay on top of the homework, stay up on all of the other activities, make sure you have all your labs turned in. And some of you guys, I sit there, I said, hey, you messed up on this, you still can turn it in and get it fixed. I've given you opportunities like that, right? So again, I am not out to, like, I don't know what it is. Students believe that I'm out to get them. I am not out to get you. I want to see you succeed. But I want to make sure that if you succeed in this class, you've earned that grade, right? And so either you earn it by working your ass off, or you earn it because you're like a genius, right? Or you're a combination of both. That's what I'm trying to present. I want combinations of both because hard workers are going to make it, right? People who are brainiacs can make it if they're hard workers,
So even if we did all the work, all the homework, the labs and everything, and let's say per se we got a C or a D in the test,
you could still pass the class with a C or a B, the thing is your test grade is only a part of your grade. You still have the other stuff. If you've done your other stuff, you didn't miss those assignments because, there's a tendency, there's a couple of you guys, you kind of get overwhelmed by life and you stop doing homework, right? That's detrimental because those are points that you're going to, you get ample opportunities to do them over and over and over again. So there's no reason that you shouldn't have 100% of your homework, right? And then I go back over your quizzes eventually and I give you points because you attempted everything. So I go over and I look at it, did you attempt? So I give you full credit for your practice quiz. So really the only way that you hurt yourself is by not participating, by not doing the labs, by not following instructions, which are things that you need to know how to do, right?
Yeah. One more thing, Dr. Henry, I believe on Tuesday you say you were going to extend the date on that extra credit.
Yes, I need to open it back up.
But I couldn't submit it. So
my bad. So let me open that up right now.
What extra credit?
The drawings of two
the hydrocarbon, the branch hydrocarbon, and the other thing, right?
Yeah.
So can I just ask who's sharing their screen? Because I want to ask him for help.
It's Edgar.
Edgar, can we ask her for help to do it?
I mean, that's fine. Like, you can see I'm struggling because Google Sheets is weird and it refuses to let me.
Well, you're perfectly done. I basically need help with the math part.
Edgar, can you show me what your I don't know, they're called like commands or something for your volume? Can you click on it?
Yeah, which one? Volume?
Yeah,
Which
the
one?
first one. Volume centimeters. cubed.
So right here, this is it. So it's 4/3 times. So you just put in pi parentheses and
Can you like zoom that in? I'm sorry to interrupt you.
yeah,
You can't see nothing.
let me see if I can.
We're
I'm
all
blind.
blind.
We're all
There we go.
blind.
Perfect.
So yeah, it's 4/3 times, and then you just put pi and then close parentheses with nothing in it, and it already knows what you're talking about.
Yeah, okay, because I kept getting value hashtag. Okay,
Yeah,
thank
and
you.
then yeah, diameter, divide by 2 to the power of 3. Easy enough.
Okay, so you should be able to do it now. Let's see, in Hartnell, let me get you guys set up too. Sure.
All right, Dr. Andrea, I'm all set and I'll be able to do the calculations easily now.
Okay. So you're
I
set.
will, I will see you Tuesday.
Okay. You guys have well, whoever's leaving, you're welcome to stay. I have a few more minutes before I'm crashing out. But those who are leaving, you want to go? Bye. Have a good night.
See you, Dr. Henry. Thank you.
No problem.
Dr. Henry, where's the extra credit under?
It should be under modules. And I'm opening yours back up so that for the
Was it for the organic structures?
yeah.
Okay. It's
Yeah, so you should be able to submit it too. It'll show up it'll show up as late, but it'll be able to be. Okay. Anything else?
Thank you. Have a good
So
night.
the test opens up on Friday and closes on Tuesday. Is that correct?
That's correct.
Is a practice test already available?
Yes, it is.
Okay.
So we have the whole weekend to do it.
Yep.
We have the whole weekend to study and then do it.
Yep.
Okay. Thank you, Dr. Henry.
Okay. You guys have a good night.
You too.
Thank you.
I'll see you guys Tuesday.